Hello, so we're going to be getting started now with our discussion of motion, okay? And kinematics is kind of the term that they use to, in physics to, I guess, label this discussion. And honestly, this is kind of a bunch of gibberish, but we're talking about motion. And when we talk about motion, this first chapter, to make things a little simpler, we're going to just say that things are going in a straight line. So this is it's common to start off talking about motion with motion in one dimension. Okay, let's change the color so we can see a little better. So this is one-dimensional motion, so things moving back and forth along a line. Okay. Later we'll talk about motion in two dimensions, so that would be things moving around in a coordinate plane. But it's helpful if we can master the motion in one dimension first before we get into that. And also, we're not going to be focusing on a given cause. So we're not talking about why the things are moving, and if the motion changes, we're not so much talking about why it changes. We will eventually, but just to get started, we won't worry about what's causing it to move. We're just going to worry about how it's like what's going on with its motion. Okay? And then we're going to talk about particles, okay? And this is this might be kind of confusing at first, but basically it's like this. If I want to talk about, say, the motion of a car, and you guys are going to get an early introduction to my awesome drawing skills. Okay, so here's a car, and if we're talking about the motion of this car, we have these wheels here, they're turning, right? We have these wheels turning. Maybe you have the window, could be rolling up or down, and then there's people in the car, and but in general, all of these things are moving together in a certain way. So maybe it's moving this way. And so when we talk about the motion of the car, it's simpler. Instead of talking about all the car as a whole, because the car as a whole can do some complicated things in addition to moving in a straight line, we're just going to say, okay, at the average location of this car's mass, we're going to put a point, and we're going to talk about how that point is moving. Okay, we're going to ignore everything else and just pretend that this car is acting at this point. Okay, and generally it's okay to simplify things that way. Sometimes we can get into trouble, and we'll talk about that later in the course. But for now, it's just going to make things a lot easier if we just take this car and pretend it's just acting at this little point right here. Okay? So as we get started in our discussion of motion, there's a couple of vocabulary terms that we should probably know before we start talking about it, okay? So let's go to that now. Okay, so when we talk about quantities in physics, quantities being things that we can measure, those things that we can measure kind of fall into two different groups, okay? One group of things are considered to be scalars. The other group of things are considered to be vectors. And we're going to get a very simple definition of these things today. And probably will, in a couple chapters, we'll go back into it and get a little bit deeper of a definition. But for now, we're just going to talk about the things that matter, okay, for what we're talking about in this chapter. So a vector and a scalar are two different kind of types of quantities. So a vector is something that has direction. Let's change the color of this so that it will stand out. Okay. A vector is something that has direction. Okay. And so vectors have direction. Okay. Meaning, like, if we have a vector, let's go ahead and draw one. So a vector is something we draw with an arrow. Okay, and the direction that arrow is pointing is significant. Okay, so this arrow could be an example of a vector. Okay, you see it's pointing somewhere. Okay, they have direction, and then they also have magnitude. Okay, so vectors also have magnitude. Okay, magnitude is a fancy word for saying how much or how big. So they have size, okay? And it's going to turn out that scalars also have magnitude. Okay? And here's our vector scalar Venn diagram. Okay? So vector has direction, can have magnitude. Scalar can have magnitude. Does a scalar have directions? No. Okay, and so along those same lines, we got one other thing. If it has directions, the way that we denote the directions for a vector is by using a positive or a negative sign. Okay, at least when we're in one dimension. Okay, so a vector can be positive direction, negative direction, and those positive and negatives are just a way for us to reference which way it's going relative to another one. Okay. Okay, so a couple other pieces of information, some more vocabulary words. So we'll talk about the origin. You may be familiar with the origin from graphing, where origin is this 0, 0 point. Okay. When we talk about physics, the origin is a little bit more open to what it could mean. Okay. It's a reference point. It's the point that we're saying is 0. So the thing that that you'll get used to in physics is that when you are analyzing a situation, the origin is a place that you determine. So you can say this place right here is the origin, and someone else could be solving the same question, analyzing the same situation, say that this place right here is the origin. And the physics will work from either place. Okay, all the rules still apply to either place, and you can choose to place your origin when you're solving questions wherever you want. In that same note, when you set your origin or your reference point, you also choose which way is positive. So if your one-dimensional problem is going up and down, you could say that up is positive if you want. Or if you want, you could say, no, I don't want up to be positive. I want down to be positive. And someone else doing the same thing might say, well, I want up to be positive because that makes more sense to me. And same thing to left to right. So traditionally, I think we'll say that the right is positive, and that's what I'll generally do, and the left is negative. But if you want, you're working on a problem that makes sense to you, you can say that right is negative and left is positive. Okay, that's totally up to you. All right, so now that we've got origin out of the way, let's talk about position. So the next word I'm going to talk about is position. Okay, and we'll denote position with an X. Okay, we'll call it X1 or X2, or you could call it X0 or Y or something. Okay, and a position is a location relative to the origin. Okay, and position is a vector. Okay, so what does that mean about position if it's a vector? Well, if you remember, that means that it has direction and it has magnitude, or how much, and that means it's expressed with an arrow. So if we have a number line, okay, and something has a position of 2 meters, that means we have a vector pointing from here that goes to 2 meters. Okay? Now, sometimes, and in a very narrow range of circumstances that at least that we'll encounter, it makes sense to, instead of drawing an arrow, just to put a point. Okay? So position is a vector, but we're just going to treat it as a point, and this is probably really the only time we'll do this. Okay? And so, because we're going to be looking at how the points change, and it's easier to look at the change as a vector as opposed to the position itself. It will get a little bit overwhelming if we have all these arrows going all over the place. Okay, so, but we have a magnitude, 2 meters, and a direction to the positive. Okay, and then we have, we'll talk about right now displacement too, which is also a vector, an amount, and a direction. Okay, and displacement is defined as a change in position. Okay, so the displacement is the change in position. So if we started at position 0 and went to position 2, we would find our change in position and have a displacement of 2. Okay, generally for position and displacement, we'll use the unit meter. So if these were 2 meters, that would be a displacement of 2 meters. Okay, there is a really significant thing here though, and this is something that can get really confusing if you don't understand what displacement means, because displacement is just simply defined as this, the change in position of an object. Okay, and so to give you an example, let's say that this is a track. Okay, track is about how far around? 400 meters. Okay, and so let's say that you're starting a race here. Well, if you run around that track, let's say you're going to run a 5K around this track, so you got to run like 12 and some change laps. Okay, so we're running. Let's say they end up right back where we started. Okay, what would be our displacement? What's our change in position? Let's say that we ran 3 laps. What was our change in position? Well, based on this definition, our starting position would have been 0, so x1 would be 0. Our ending position, we ended right here at the beginning of the track, so that would also be 0. Okay, so our displacement in that case would be 0 meters, because you've traveled all around the track, but displacement, just talking about your relative position, you ended up right back where you started, so you have 0 displacement. Okay? And this is something that can get really confusing if you don't understand displacement. As I said, when we start talking about two-dimensional motion, you've got to remember this. Displacement, just the change in position. Doesn't have to do with anything. You could have someone who is just really struggling to run in a straight line. They're kind of zigzagging all around the track. And clearly they've run a lot further than the other person, but their displacement's still the same. Okay? And let's say that you're traveling from your house to school. Okay, so here's one location, here's the other. You could fly straight there. Let's say that you had like a pet bird that could pick you up and fly there. Or you could make this like meandering path, take your time exploring and stuff, finally end up at school. And in both these cases, the displacement is the same because this position to that position has the same amount of change. Okay, now it's very easy to confuse displacement with distance. Okay, and distance is a scalar, meaning no direction, just magnitude, just the how much. Okay, and the how much for distance is the length of the path. Okay, and so when you want to account for the fact that something went further, that's where distance comes in. Okay, if you were looking at these two paths, clearly you traveled further going that way than you did going that way. Okay, but in the case that these two paths have the same displacement, one of them has traveled a greater distance. Okay, and that's a really important distinction for us to understand. So we'll wrap this up by doing a little bit of practice. So here we have an example where we have 3 pairs of initial and final positions, and they're along an x-axis, and the question is which pairs give a negative displacement. So go ahead and take a look and decide which pairs give you a negative displacement if the one on the left is the starting position and the one on the right is the ending position. Okay, so let's go ahead and find out, and we'll go ahead and calculate these displacements as well. So remember that displacement, change in position, final, oops. All right, that means it's the final position, position 2, minus the initial position. Okay, so 5 minus negative 3 is going to be 8 meters. Okay, negative 7 minus negative 3 going to be negative 4 meters. And negative 3 minus 7 gives us negative 10 meters. So it appears that options B and C both give us negative displacement. Okay, whereas option A gives a positive displacement. Okay, so the last scenario we're going to look at, let's say that you start at your house. Okay, let's say you go to school, a distance of, we'll say 1.5 kilometers away. And let's say that, you go to school in the morning, after school you come back home. So what would be your displacement from the morning to the evening when you get back home? Hopefully put displacement with 0 because you ended back up where you started. Okay. If you were thinking, these are kilometers. If you were thinking 3 kilometers, that would have been the length of your path or the distance.